All right, so far we have talked about the different types of angles we've talked about have been central angles, the angles that are at the center. We have talked about inscribed angles. That's when the angle is sitting right on the circle. And now we're going to fill in those last two boxes, which are interior angles and outside angles. So interior angles are located inside of the circle. And specifically inside of the circle that's anywhere else aside from the center. Because when we have the center, the angle and the arc are just the same. But when our angles are inside of the circle, then our formula is that to get this angle that's inside of the circle, we are going to average the arcs together. And I find an average by adding together and dividing by 2. So our formula is going to be add our arcs, divide by 2. So to take the example that I kind of drew here, I drew an example where I gave this arc up here is 20, and this arc down here is 120. So that would make the angle, add the arcs, divide by 2, so I'd have 20 plus 120 divided by 2. So that's 140 divided by 2, which is 70. So this angle here would be 70 degrees. Which means, from vertical angles, that this angle would also be 70. So add the arcs, divide by 2 whenever our angle is inside of the circle. Next. We have outside angles. This is our last box, and this can be drawn a few different ways here. So you're going to see it drawn a few different ways. But our formula is going to be the same regardless of how it's drawn. As long as the vertex is outside of the circle, then our formula, let me show that part real quick. Our formula for the angle is to take the outer arc minus the inner arc and divide it by 2. So when we had the angles inside the circle, we added and divided by 2. Now that the angle is outside of the circle, we're going to subtract and divide by 2. The outer arc comes first because the outer arc is the bigger number. So then it subtracts the smaller number and it gives a positive angle measure. So let me show you how these are drawn, and this will give you a couple of examples to look at here too. So the first one is when both segments of the angle are crossing through inside, like this. So the angle is out here, outside of the circle. Again, outer minus inner over 2. Outer arc, the outer arc is farther away, is the arc that's farther away from the angle, and the inner arc is the one that's closer to the angle. That's how you can tell which one's which. So the outer arc is the farther away, inner arc is the closer. So outer arc is 70 minus the inner arc, which is 20, over 2. So that is 70 minus 20 is 50, divided by 2 is 25. So outer arc minus inner arc divided by 2. Watch it happen again. In this example, one of them is cutting through. It's a secant. But this one is just crossing through the outside. This is a tangent because it's only crossing through at one point. So in this case, the angle, still outer minus inner divided by 2. Let me draw my outer and my inner. Here's the angle. My inner arc is the one that's closer, so this one. My outer arc is over here. The rest of the circle is not included because it's not along the kind of interior of the angle. So here's my outer arc, here's my inner arc. So we'd have 150 minus 80, outer arc minus inner arc divided by 2. That's 70 over 2 is 35. So again, still outer minus inner divided by 2. And again, these are kind of examples to give you so that you see how the formula works. Here, let me. All right, one more example here. This one's a little trickier because it's still located outside the circle, but this time it's crossing through. It never slices through inside. So our ends of our arcs are going to be right along the outside. These are tangents because they just cross through at one point like this. So my outer arc is the farthest away from the angle. That's the 240. Start at this point, crosses along the outside to here. And notice I didn't give you the inner arc. So we need to figure out how to get the inner arc. Well, in this case, my inner arc, if I trace it out, it also starts at this point and ends at this point. So when I trace out that inner arc combined with the outer arc, click, it's made the whole circle if I put those two arcs together. And we know the whole circle, we know all the way around my circle is 360 degrees. So to find that missing piece, I can just take 360 and subtract 240. And that ends up being 120. So when I want to get the angle, it's going to be outer minus inner. I got my inner by subtracting from 360. My inner arc, or my outer arc is 240. My inner arc is 120. Divide that by 2. 240 minus 120 is 120. Divided by 2 is 60. So that's just giving a couple of kind of extra examples here of the basic form of the formula. So now we're going to make things a bit more complicated. There's going to be some equations in this involved here. So now we're going to be moving to the back page. And we're going to do the first half of these examples today. And I'm going to finish the second half of the examples in the video tomorrow. And that should go quicker because I've already shown all the formulas and we've done some examples with them. So I'm going to go through them quicker tomorrow. Find the value of each arc or angle that we're looking for. So let's start with arc 1 over here. These are all interior angles. These are all angles that are inside the circle. So the formula that we're going to use here is that the angle is, add the arcs, divide by 2. That's the formula we're going to use. So the angle here that we're using to trace out this arc is this angle right here. The angle across from it, because those are the angles that we're using. We're finding the angle that's across from it is this one right here. So we're tracing out basically the arcs that are kind of across from each other, and that's what we're going to use in our formula. I'm going to use X for this piece that I don't know here. Here's the angle. Here's my 2 arcs that are traced out from those angles. This is 70. This is also 70. So these match because of vertical angles. That does not happen with the arcs. Notice that this arc is not 70. It would be if the vertex were at the center. When we had our central angles where the angle is right at the center, then the angle and the arc were the same measurement. But now that it's somewhere else in the circle, the measurements are different. So now that's why we're using this formula. Careful here. Our angle is 70 degrees. So the angle, which is 70, goes on the left side. Equals, I want to add my arcs and divide by 2. Add my arcs and divide by 2. My first arc over here is 66. And then my second arc over here, I don't know it. So we actually wind up with an equation. Again, that happened because instead of solving for the angle, I already know the angle, so it goes on that left side. And this arc, which is what I don't know, is ending up on the right side. So now I have an equation that I need to solve. And so we're going to multiply by what's on the bottom to get rid of the fraction. That's how we usually start anytime we got a fraction in one of these problems. I got 2 times 70 is 140. Over here, the 2's cancel and no more fraction. That was the goal of multiplying by 2, so that I had no more fraction. And now it becomes pretty straightforward. We're going to subtract from both sides. and that's going to give us 74. So this is 74. Okay. Then I want arc number 2. So I'm going to label this. Y since we already used X. This arc, we can actually find 2 different ways. I'm going to show you how we would set up both of them. The advantage of method number 1 that I'm going to show you is that it's not going to rely on you getting the first arc correct to get the second arc. So even if you messed up here or didn't know how to do this one, you could still figure this one out. And it's very similar to the formula we used to get the first one. That's the advantage of way number 1. The advantage of way number 2 is that it's faster. So a lot of you may prefer that, but use whichever one makes the most sense to you. Here's method number 1. Method number 1 says, I'm going to put method number 1 in blue. Method number 1 says that I can figure out what this angle over here is, because I know this angle is 70. If I know this angle is 70, then these two right here make a straight line. They're a linear pair. So if this is 70, it should combine to make a straight line which measures 180 degrees. So if this is 70, this would be 110. And then this would be 110 as well, by the same reasoning. So because I know that this angle has to be 110 because here's a linear pair, here's a straight line, or here's a linear pair, here's a straight line. Since I know that angle is 110, I can use basically the same setup that I just used to solve for x and use it to solve for y. 110 is my angle, equals, add the arcs, divide by 2. My 2 arcs are 126. And then the one I don't know. And I'd solve for y. So I'd use a linear pair to get that other angle measure, which would let me set up the other formula. Because here are my 2 arcs that are coming off of those angles. And look, there's the one I'm trying to solve for. Method number 2, I'm putting in green. Method number 2 relies on something that we did a lot last week, which is, hey, would you look at that? I have, right now in front of me, I have all of the arcs in the circle except for one. And anytime I know all of the measurements except for one in the circle, then I can use the fact that all of the measurements in the circle, when put together, should be 360, because it's all the way around the circle. So again, I can use all the way around the circle is 360 degrees. So let's trace all the way around the circle. Watch closely here. Tracing all the way around the circle, I have a 66 here. I have 126 here. I have a 74 here. I have y here. Ding! We went all the way around the circle. So there's my equation. I had 4 different arcs, and when I put all those pieces together, I would get 360 degrees. So either of these equations works. One of them used a linear pair to get the same formula with the interior angles, and the other way used all the way around the circle being 360 degrees. So sometimes there's more than one way to get the answers. Either way, with either equation, you should be able to solve and get that y is 94 degrees. If you solve either of those equations for both of them, you should get 94. Questions on that? That was the longer one. The rest of these are going to be shorter. All right. Next up. Angles are still inside the circle. Boom, right there. We're going to start with angle 1. Angle across from it is this one. So we're going to trace out those arcs. This arc starts up here and ends down here. And then this arc from the angle starts here and ends here. So it's the two arcs that are traced out from the angle and the space inside of those two angles. There's the side I don't know. That's the part I don't know. And it's this time it is the angle that I don't know. So I'm going to put x in for the angle. Equals, add the arcs divided by 2. I know both of the arcs. Both of the arcs are 33 and 131 over 2. And that's nice and easy. I can just add these divided by 2. 33 and 131 should be 164. Divided by 2 is going to be 82 degrees. Again, the difference in these two problems is that over here, this one on the right, the angle was the thing I didn't know, so it went by itself on the left side. On this one, the arc was what I didn't know. This arc over here in red was what I didn't know. And so I needed to put it with the arc on the right side of the equation, since that's where the arcs go. And so that ended up being an equation where I needed to solve for x. On this one, since the angle is what I didn't know, x was already by itself. So this is 82 degrees. Oh, and we can use what we had just talked about with the linear pair. We can use it again to get angle 2. These two angles put together make a straight line. Straight line is 180 degrees. So to find the measure of angle 2, I just take 180 and I subtract the angle that I just found, which was 82, and that should tell me the other angle being 98. So those are some examples with the angle being inside of the circle. Add the arcs divided by 2. Next group. Next pair of problems here. Find the value of each numbered arc or angle. These angles are outside of the circle. These are outside angles. So our formula this time is that the angle equals outer arc minus inner arc divided by 2. Outer arc minus inner arc divided by 2. So I'm going to start with this one over here. It's the easier example here. There's the angle. I don't know it. I'm trying to solve for it. Remember, if I trace out the angle here, the arcs should all be contained within the angle that I trace out. So that means the first arc comes from here to here. All the arcs that I make are going to be inside of this zone. So this is my inner arc. I know it's the inner arc because it's the one that's closer to the angle. It's also the smaller one. So the inner arc closer to the angle. The outer arc is the one that's farther away from the angle. So here's my outer, here's my inner. Outer's the one that's farther away, inner's the one that's closer. So my angle, I don't know it. Outer minus inner over 2. So my outer arc is 92 minus my inner is 43 over 2. That is 49 over 2, which is 24.5 degrees. Yes. Minus. So again, when we were doing the inside ones, when they were inside the circle, we added divided by 2. Now that we're outside the circle, our formula is subtract divided by 2. All right, now let's go back to this one. And we actually did an example like this one already when we first wrote down the outside angles. Here's the angle getting traced out. So over here, my start and end points were here to here. And then for my outer arc, my start and end points were here to here. Over here, here's my start and end point. And so for the outer arc, I'm going to trace along the outside, the side that's farthest away from my angle. There's my outer arc. To get my inner arc, I'm still going to start here and end here, but this time I'm going to trace inside closer to the angle. Right, because here's the angle I'm trying to find. Oh, click. We have the whole circle again. So I know this part is 270. So this part here in green has to be the rest of the circle. So the whole circle, still 360 degrees. So the other part of it is going to be 360. Subtract off the part I already have, which is 270, which I get 90 degrees. So that is my inner arc. Outer minus inner over 2. So this angle is what I'm trying to solve for. And it equals the outer arc, which is 270, minus the inner arc, which I just found by taking 360 minus that outer arc to get the inner arc. It ended up being 90 over 2. And when I work this out, this answer is also going to be 90. 270 minus 90 is 180, divided by 2 is 90. So 90 degrees is the measure of that angle. So to get this inner arc, we subtracted from 360. It completed the entire rest of the circle. We did not do that over here. Right? These two don't make 360 because these two don't make the entire way around the circle. We have all this space over here that isn't taken up.